Now let's look at some more multiplying of polynomials. These are a little different than what we've seen before because we don't have just one item by itself. In each of the parentheses we have two things. We call that a binomial. So we're going to multiply a binomial times a binomial. We're going to use some of the ideas that we had when we distributed in that we want to multiply this w times each of the pieces in the second parenthesis, and then we want to distribute this -3 to each of the pieces in the second parenthesis. So let's start by distributing the w. So we would have w times 2w, that would be 2w squared, and we would have w times 5, which would be plus 5w. Then we'd multiply -3 times 2w, that would be a -6w, and -3 times positive 5 would be a -15. Now when we do this multiplying, we want to then combine like terms if we have any. So we would get 2w squared minus 1w minus 15. And then that's as simple as we can make it, and that's what our answer would be. Now we have something to help us remember how to do that. And so oftentimes we will call these kind of problems FOIL problems, where we have two numbers in one parenthesis multiplied by two numbers in the second parenthesis. So remember, we distributed that w, and that's the first number in the first parenthesis, and we wanted to multiply that by the 2w, which is the first number in the second parenthesis. So the F in FOIL stands for first. We want to multiply the first number in each of the parentheses together. And then we want to multiply the w times the 5. And so that would be the w and the 5 being the outer numbers of the two parentheses. So O stands for outer. So if we look at what we have so far then, going back to our problem of w minus 3, that quantity times the quantity of 2w plus 5, we want to multiply the w times the 2w, that is the F of FOIL, and that got us the 2w squared. And then we want to multiply the w times the 5, that is the O of FOIL, the two outside numbers, and that's going to give us a positive 5w. Then we have the I. The next thing we did was distribute the -3. So we took the -3 times the 2w. Well, the -3 times the 2w would be the two numbers inside, the closest together inside those parentheses. And so I stands for inner. And so when we took -3 times 2w, got a -6w. And then we want to multiply that -3 times the positive 5. So when we take the -3 times the positive 5, the -3 and the positive 5 are the last numbers in each of the parentheses. So the L stands for last. And when we multiply -3 times positive 5, we got a -15. And then we want to try and combine like terms. Now, most likely, if we can combine like terms, that will happen with the inners and the outers of FOIL. So we ended up then with 2w squared minus 1w minus 15. And so FOIL will help us remember how we can do that. So let's use that idea of FOIL to do this second example. We have 9k minus 7, that quantity times the quantity of 3k minus 4. So the F of FOIL would say to take the 9k times the 3k. So 9 times 3, 27. K times k is k squared. Then we want the O of FOIL, and that stands for the outer, the two outside numbers. So we have a 9k times a -4. So 9 times -4 is -36 times k. Then we have the I of FOIL, so we're going to distribute that -7. So we have -7 times 3k, the two inside closest together numbers, and so -7 times 3k would be -21k. And finally we're going to take that -7 times the -4, and that's going to give us a positive 28. That would be the L of FOIL. So now let's combine like terms, keeping in mind it's the inners and the outers of FOIL that we generally are able to combine. So we would have 27k squared, and then a minus 36k minus 21k would give us a minus or a -57k. plus 28. And that would be our answer then, 27k squared minus 57k plus 28. Let's look at one more FOIL problem, and that would be the quantity of m minus 8 times the quantity of m plus 8. So FOIL says to take the first number in each parenthesis and multiply it together, so there would be our f of FOIL, so that would be m times m, or m squared. Then we want to take the outside numbers, so we want to take m times positive 8 for the outers of FOIL, so that would give us a positive 8m. Then we want to distribute the negative 8, and to do that, that's the I of FOIL, the two inside numbers together, so negative 8 times m would be a negative 8m. And then the L of FOIL would say to take the negative 8 times the positive 8, and that would give us a negative 64. Now combining like terms, again looking for those inners and outers of FOIL, we would get m squared, and then a positive 8m minus 8m would be 0m, in which case we don't have to write that, we don't have anything, because 0 times any number is just 0, and then the negative 64. So in this situation, the inners and the outers of FOIL canceled each other out, and we just have m squared minus 64. So that would end our FOIL type problems. We do have one more type of distributing problem, or one more type of problem we encounter in this section, and that's taking a binomial times a trinomial. Now I would tend to write the binomial first because it's less to distribute. And to help me distribute, I'm going to actually draw some arrows, because what I need to do is take this 2x and multiply it by each of the numbers in that second parenthesis. So I have to take 2x times the 4x squared. That will give me an 8x cubed. And then I want to take 2x times negative 3. Now remember that negative goes with the 3. That will give me a negative 6x squared. And I need to take 2x times a positive 9. So that will give me a positive 18x. Now I need to distribute the 5. So I'm going to take the 5 times the 4x squared for a positive 20x squared. The 5 times the negative 3x will give me a negative 15x. And 5 times positive 9 will give me a positive 45. And then I need to combine like terms. So I have 8x cubed, and I can combine the negative 6x squared with the positive 20x squared for a positive 14x squared. I can also combine the positive 18x with the negative 15x, and that will give me a positive 3x, and then plus 45. And so we would get 8x cubed plus 14x squared plus 3x plus 45. So that completes our examples on multiplying polynomials. Good luck on your homework.